Hello, friends. Today we're continuing our study of geometry, and we're going to do it this time with what are called constructions. Okay. In some textbooks, they're called labs. The whole idea is to see what we can construct, what types of figures we can construct using only a compass and a straight edge. We're talking about this part. Obviously, this has the angles as well, but uh, so what are these for? Well, the straight edge is just for connecting any 2 points. What this does is it gives you distance. Right. So if I fix this in place, and so I like a compass that has a lock on it because I can lock this and now it's not going to, slide when I'm trying to do this, trying to use it. But now I can find any 2 points and make sure that they are the same distance. And I can even draw, or I can fix this in place and draw. I also like this one because I can put anything in here that I want, pencil, pen, I got this lock screw in there. This one has a point, really sharp point, but then when I close it, it retracts for safety. Okay, so let's take a look at our first construction. Okay, just congruent segments. That's all we're trying to get here. So again, that's lines that have the same length. So if I want them to have the same length, what I'm going to do is I'm going to start with a particular point. I'm going to put the tip of the compass down on that point, and I can choose any length here that I want, any kind of distance. And I'm not using the numbers. The whole idea is to try to do all this without using any measurements of numbers, but just using the compass the way it is, and then the straight edge to connect points. Now the thing is, because of the way the compass works, I now know that between this point and these points over here, any of these points are the same distance from that one point. So let me use a pencil instead. Okay, and so I can connect from here to here, and from here to here, from here to here. And so I know that all of these segments are congruent with each other. Right? Okay, very simple. Now, construction 2. This is where I'm going to be trying to make congruent angles. Okay, so I'm going to start with any angle I want. So I can make a random angle here. Put arrows on the end of it if you want. And we're going to label these points, label them M, A, T for math, but also for Matthew because that's my first name. So now I've got this angle MAT. So now I'm going to try to construct a congruent angle. And I start just by drawing this segment. And I'll label this G, E. No, I don't want to. Oh, no, I can. Yeah. So here's what I'm going to do. Now I'm going to measure this. So I'm going to measure the distance between A and T like that. I'm going to lock this in place. Oh, it was pretty close. And so now I'm actually going to draw an angle here. Oops. Press down here and then just turn. Okay. And I'm going to label this point E. Okay, I'm going to have that same angle up here. Go like this. Whoops, doing the wrong thing. All right, so I put this down here. Okay, and so now the whole idea is this, that the distance from here to here then is going to, or from this point, actually, the intersection between the arc and this line, the distance from here to here is going to be the same if I make a congruent angle over here. So I'm going to get this distance now, the distance between M and T. So I'm going to unlock, find that distance. Now I'm going to lock this in place. So I like the lock because it allows me to do that. And so now, but how am I going to know where that is here? Well, it's the intersection, right? It's the intersection between the line and the between the line and that arc that I drew. So that is the point of intersection. So this now is a point here. So now I just connect the 2 points from G to there. We'll call this point O, like for geometry. And now I know that these 2 angles are congruent to each other. What I'm going to do in this construction is draw a line that is perpendicular to a point on the line. So I'm just going to pick any kind of random point here. Call this point M. So I like doing that. And so now what I'm going to do is I'm going to find 2 points that are the same distance from M. Okay. And the way I'm going to do that, it can be any distance really, but as long as it's the same distance on both sides. So I'm going to make a little arc there and make an arc here. I kept this tip in the same place. So now these 2 arcs that I made are the same distance away. So A and T. Okay. So now, if I'm going to draw a line that's perpendicular, I want to make sure this is perpendicular. What that means is the 2 points above and below are going to be the same distance from A and from T. So I'm going to go here now. I'm going to put the tip on point T, but I have to go past point M. So I'm going to stretch this out. And I have to go past point M. I'm going to draw a big arc like that. Okay, I'm making sure that this arc goes past where point M is, just to show you, right? So here's M, and the arc is going past that. So, and now I go over to A, because I want this to be the same distance from A, like that. And now look, I've got these 2 points of intersection. So this point and this point, I know that this point is the same distance from A as it is from T. And at this point here also the same distance from A as from T. And now I can connect, I'm right-handed, so it's a little easier to do it this way. I connect this top point and this bottom point, and it should go right through point M. And so now I've made a segment that is perpendicular to this line. Put that little symbol on it, like that. And you can continue the line past either way, doesn't matter. But the whole idea here is that by doing this, I've made a line segment that is perpendicular to line AT. Our fourth construction is going to be making a perpendicular bisector, symbol for perpendicular. And so first thing I need to do is get a segment, and this segment can be of any length. Okay, call this segment MD, segment MD, and I'm going to find the perpendicular bisector of this segment. And I'm going to do it very similar to the way I did construction 3. I'm going to guess where I think the middle is, probably around there somewhere. I'm going to go a little bit beyond that, just a little bit beyond where I think the middle is, and going to make an arc, kind of a big arc, because I want to make sure I get past the midpoint. I'm kind of crossing over. And now I keep the same distance, move this over. Like that. And so now all I have to do is connect from here to here. And so this line, it's here, it's perpendicular, and it's the bisector of segment MD. Now, there are a couple things that come out of this. Notice then that this distance, right? So any point on the perpendicular bisector is the same distance from the ends of the segment. Okay, so Here's a postulate. Any point on the perpendicular bisector is the same distance from the ends of the segment. Okay, and then a theorem, rather. Actually, it's not a theorem. It's not a postulate. This is a theorem. Theorem. Again, we'll get more into the difference between postulates and theorems later. The idea is a theorem is something we can prove. There's another theorem as well, and it's basically this just flipped. So the idea is that if um, if any point is the same distance from the endpoints of a segment, it is on the perpendicular bisector. Okay. So now another construction. Construction 4. This time we're going to be making an angle bisector. Sorry, this is construction 5, I guess. Angle bisector. So I'm going to start by making any angle that I want. So something like this. And I'm going to call this point A. And what I want to do is find 2 points that are the same distance from point A. So I've already got this set. Where I set this doesn't matter, but as long as it's the same here and here. We'll call this B. We'll call this C. And the whole idea with an angle bisector is that I want this to be in the middle, the same distance from B and C now. Okay. So what I'm going to do is put the point here, and then I'm going to be somewhere in the middle. I'm going to start with this pointing at B, and then draw an arc like that, where I think I'm crossing over the line that's kind of going through the middle here. And now, keeping this the same distance, start at B, pointing at C, come around this way, right, going like that. And now I get the place where this meets. So this point here, this point is the same distance from B and from C. So then all I have to do is connect this from there to there. Let's call this point D. So BD is the angle bisector of angle BAC. Okay, out of this we get another couple of theorems, right? We call this the angle bisector theorem. Uh, if we're going to say, yeah, if a point is on an angle bisector, it is the same distance from both sides. And then again, you flip this around and you get the same point, but just flipped, because it also proves the other way that if a point is the same distance from both sides of an angle, it is on the angle bisector. Okay, so those are our first constructions, kind of what you'd call our labs in geometry. Classic geometry, some that really comes out of ancient Greece. They just had straight edges and compasses, and they wanted to see what could they construct. And so there's some basic things, right? Congruent segments, congruent angles, perpendicular lines, perpendicular bisector, and angle bisector. Thanks for watching. Don't forget to like and subscribe.